So welcome everybody to this latest video on 162 Maths, and in this A-level A2 video we'll be continuing from partial fractions introductions and looking at where we write partial fractions where you've got two linear functions in the denominator of your algebraic fraction. So continuing from the introduction, this method is used when you have a quadratic which is often already factorised as a denominator and a linear function or a constant in the numerator. So in these two examples you can see on the screen. So here we've got a linear function, so we've got something in terms of x. So this is our linear function. Now the reason why it's got to be a linear function, so you've only got a single power of x, is because otherwise because you've got two linear functions as the denominator, you're generally going to end up with a quadratic at the bottom of the denominator. And if you have anything that's beyond a linear function, it would then make it where you've got the same degree of x or an improper fraction. It's quite difficult to spot, but you tend to find that the power of the x at the bottom generally needs to be bigger than the one at the top. And also you can also therefore have a constant. So not everything needs to have something in terms of x in your numerator. It can be just a single x or it can be a constant. And again here we've got our factorized quadratic. So if I was to expand this out, this would make a quadratic. I don't know why the pen's making random lines. And this is a unfactorized quadratic. Now if you did end up with a unfactorized quadratic, I would strongly recommend that you factorize it first. So if unfactorized, factorize first. And again, obviously if you end up with a question like this where it is unfactorized, you would probably get a mark just by factorizing it. So although there's a little bit extra work to do, it just means you're going to get more marks for that question. So let's have a look at the method. Now this method is a bit waffly and it may not make much sense unless you know what you're doing, but I will go through step by step with an example question. But if you're in sort of want to make notes and like methodology, basically like how I teach, then this is definitely the steps that you need to work on. Now at this stage, do not worry if it doesn't make any sense, but when we go through some examples, as I said, hopefully it will do. So the first thing we're going to do is break the denominator up so that each bracket is its own denominator and the numerators are labelled A and B and make equal to the original algebraic function. Now these types of questions of partial fractions can be a lot of marks. They can be up to 5, they can be up to 6 depending on what you want to do. And so it's really important that with these 4 steps, these are where you're going to gain marks. So if you were, let's say, to be more mental and you skip steps, then there is a chance you could lose working out marks if it all goes pear-shaped. So the second step is we're going to multiply both sides by the original denominator, and you should therefore lose the sight of any fractions. It should just be a normal expression or equation that we need to solve. The third step is to substitute the value of x that makes one bracket equal to 0 and find the value of a or b, and then we need to repeat the process using the other value that makes the other bracket that we've not used make equal to 0 to find the other respective a and b value. Now sometimes A and B more difficult high level questions could be a non-positive or non-integer, say it can be positive or negative, but if it is not an integer, then leave it as a fraction. Do not go into decimals, because like I said, a big no-no is you're writing decimals in a fraction. And the fourth step is then to substitute the values of A and B and write it in the way that the question's asking you to do. So sometimes it might ask you to state the values of A and B, sometimes it may ask you to rewrite the algebraic fraction into 2 smaller fractions. So let's put this into practice in terms of an example question. So in this first example here we've been asked to write 3x minus 1 over x plus 3 x minus 2 in the form of our 2 smaller fractions. Now the first part, which the first methodology says break the denominator up so that each bracket is its own denominator and numerators labelled A and B and make equal to the algebraic fraction. Now in this particular question that's actually been already done for me. So what we need to do is make this equal to something that looks like this. Now as you can see here I've got one bracket and I've got another bracket. So with the first bracket I'm going to have that over A, and with the second bracket I'm going to have that over B. And again, we always try and stick with the plus. Now, in your final answer, that may end up, this middle sign here may end up being a negative, but that'd be the case of if B is negative, or you may end up with A is negative, in which you might end up with a minus there. Now, just because it does show plus, and it appears that A and B are both positive integers, that might not always be the case. So just be mindful of that, that could change. So to turn this into a minus, all you need to do is have a minus B. So, but we'll go through some examples of where that is the case. So with regards to the first level, what we need to do here is our original algebraic fraction that we need to write in the form of using partial fractions. And all I'm going to do is going to make that as an identity equal to A over the first bracket, which is x plus 3, and B, which is my second bracket, which is over x minus 2. So that is my first stage. Now, in this particular question, I won't get a general mark for it because it's kind of already given to me in the question. But if it didn't, then there is a good chance I would get a mark for that first stage. Now, the second stage then says to multiply both sides by the original denominator. So what I'm going to do is I'm going to take this x plus 3, x minus 2 over to the other side by multiplying. So I'm going to multiply everything in there by x plus 3, x minus 2. So what I end up with is going to be 3x minus 1 equals, and it's going to be A, and it's going to be x plus 3, x plus 2, and that was over x plus 3, and plus B, which was over, there's that bracket, x plus 2, and I'm going to multiply that also by x plus 3, x minus plus 2. So let me just double check to make sure I've got that right. No, as you can see, I made a mistake, because that should be a minus, not a plus. So let me just correct that, because otherwise it would have ended up being a bit of a disaster. So x minus 2, x minus 2. So all I've done is I've expanded it. Now what you should notice at this stage is that this x plus 3 cancels with that, and this x minus 2 cancels with that. So what I'm left with is 3x minus 1 equals A lots of x minus 2 plus B lots of x plus 3. Now, with practice, you probably won't need to do what I'm highlighting in this green little cloud. So with practice, you'll be able to go straight from step 1, if it's given to you in the question, or whether you need to do it yourself, straight onto this line here. And there we go. So from this, that's our first stage of multiplying both sides, the original dot, and we can no longer see any fractions. So this is what I'm going to be taking over to the next stage. And that next stage then says to substitute the values of x and make one bracket equal to 0 and find the value of A and B, and then repeat the process to find the other value. So from this, what I've got is I've got 3x minus 1 is equal to A lots of x minus 2 plus B lots of x, and I've forgotten the question, x plus 3. Now, to make this bracket equal to 0, I need to make x equal to 2. And to make this bracket equal to 0, I need to make x equal minus 3. So what I'm going to do is, let's get a different colour, let's go for yellow, let's move that up. So what I'm now going to do is find the values of A and B. So when x equals 2, then this 3x minus 1 is going to be 3 times 2, which is 6, take away 1, which is 5. So let me just write down so you can see exactly what I'm doing. 3, 2 minus 1 equals A, and it's going to be 2 take away 2 plus B, 2 plus 3. Now simplifying this, simplifying the left hand side, I get 6 minus 1, which is 5, equals, now 2 take away 2 is 0, so that just disappears, so that becomes nothing, and I'm going to end up with 5b. So 5b equals 5, so therefore b equals 1. And there's my first value. Then what I'm going to do is now use the second value. So now when x equals minus 3, so when x equals minus 3, what I end up is 3 minus 3 minus 1 equals A, And it's going to be minus 3 minus 2 plus b minus 3 plus 3. So looking at this, I get 3 times minus 2, which is minus 9, minus 1 is minus 10, equals minus 3 minus 2 is minus 5, so that's going to be minus 5a, and minus 3 plus 3 disappears, so that cancels out. So what I've got is I've got minus 10 equals minus 5a, so therefore a equals 2. So now what I've done is I've now found my values of a and b. So the fourth step is all I've got to do is substitute a and b into my first step, which was this. So testing my memory, which at the moment is not great, so I've got 3x minus 1 over x plus, just I've forgotten what it was. So it was x plus 3 minus 2, so let's scroll down. X plus 3 x minus 2 is equal to, and a, which was 2, so it's going to be 2 over x plus 3 plus 1 over x minus 2, and there is my final answer. Now, a lot of students forget to actually write this. Once they found what a and b are, they tend to leave the answer as it is and they forget step 4 altogether. So it's really important that you do finish the question off by writing it in that form. If the question asks you to state the values of a and b, then that is basically what you've done in step 3. But if a question asks you to write it in the form like it did in this particular question, of writing it in this form here, then it's really important that you end your question, your answer I should say, with writing it in that form, which is clearly what I've done there. So let's have a look at another question. So sometimes it might write that, sometimes this one's asking us to write it in partial fractions. So again, I've got a quadratic at the bottom, so the first thing I'm going to do is I'm going to write this in terms of a and b. So I've got a over the first bracket, which is 2x minus 1, plus b over the second bracket, which is x plus 1. So now what I'm going to do is I'm going to take these two little brackets here and I'm going to take it over to the other side. So what I've got is I've got 5x plus 2 is equal to a lots of 2x minus 1 x plus 1 over 2x minus 1 plus b of 2x minus 1 x plus 1, and that's over x plus 1. And then obviously some brackets cancel, so that cancels with that, that cancels with that. So what I'm left with is 5x plus 2 is equal to a lots of x plus 1 plus b lots of 2x minus 1. And there you go. Now you can easily jump from this. Now what you may have spotted is basically to get from this stage to this stage I've written in blue, all you need to do is just basically swap the denominators over. So move this bracket to a and that bracket to b, and you don't need to worry about, let me just highlight this stage here. So if you didn't include that stage of crossing out and cancelling the brackets off, you're not really going to be expected to do it, but you are expected to do it correctly. So make sure you do that, and if it does help in the starting stages, then do it. So from this, I now need to find out my values of a, the x that I need to substitute. So to make this bracket equal to 0, x needs to be minus 1, and to make this bracket equal to 0, x needs to be a half. So looking at this then, let's get yellow. So when x equals minus 1, then what I end up with is 5 lots of minus 1 plus 2 equals, and it's a lots of minus 1 plus 1 plus b 2 lots of minus 1 . So simplifying all of this, we get minus 5 plus 2, which is minus 3, equals, well that's going to cancel out, so that becomes nothing, and I've got 2 times minus 1, which is minus 2, take away 1, minus 3b. So minus 3 equals minus 3b, so therefore b. And then using the other values, this I'm going to take a half, so when x equals a half. Now just be careful with plus and minuses, and obviously when you're substituting this in. So what I've got is I've got 5 lots of a half plus 2 is equal to a lots of a half plus 1 plus b lots of 2 times a half take away 1, and 5 times a half is 2.5 plus 2 is 4.5 equals, and it's going to be 1.5a, and that disappears. So if 4.5 equals 1.5a, then therefore a equals 3, and there's my second value. So then to finish the question off, all we then need to do is write 5x plus 2 over 2x minus 1, x plus 1, is equal to a. Now it's really important you do not get this muddled up. So make sure that your a goes with the a fraction, b goes with your b, because again, a very common mistake that a lot of students make. So here I've got 3 over, even though it's a second value, it's the first one you need to write. So 3 over 2x minus 1, put in brackets, doesn't really make a difference, plus 1 over x plus 1. There, my final answer. Let's try a second example. So here I haven't got a second bracket, or first bracket in this case, but it's still going to produce a quadratic. So what I've got is I can just put a bracket around there. So again, I'm going to make this equal to a over x plus b over 2x minus 5. So doing all the substitutions and taking the denominator over to the side, I get x plus 10 equals, and it's going to be a lots of the other denominator, which is 2x minus 5, plus b lots of the other denominator, which is x. Like cross multiplying, but technically not. So from this, I know that to make this bracket equal to 0, this needs to be 5 over 2. And to make this bracket equal to 0, x needs to equal 0. So when x equals 2.5, or 5 over 2, whichever floats your boat, then what I've got is I've got 2.5 plus 10 equals, now 2.5, that's going to make this bracket equal to 0, so the a disappears. So what I've got is I've got 2.5b. Adding these up, I get 12.5 equals 2.5b. So therefore b equals 5 as my first value. Then when x equals 0, I end up with 0 plus 10 equals, now that's going to basically, the b is going to disappear, so I've got a lots of 2 times 0, take away 5, which is, I'm left with 10 equals minus 5a, so a equals minus 2. There is my second value. So now I've got my two values, all I've got to do is substitute it back into this. So my final answer can be written in one or two ways. Now, if you want to go straight into it, now I personally would still write the question. A lot of students do say, so do I need to write the question out? But I'd say, yeah, it just looks better. Is equal to, and you can write it as minus 2 over x and plus 5 over 2x minus 5. Now, in mathematics, they don't like things starting with a negative unless all the components, all the terms are negative. Because obviously sometimes you can forget to write, it's a bit like the quadratic formula. Students always forget the minus, it starts with minus b. So what you might want to do is you may want to flip these two fractions around. So another way of writing this is to write the 5 first, so 2x over 5 minus 2 over x. It just might look a little bit neater, but they are exactly the same thing. So that's bear that in mind. The correct numerators are with the correct denominators and vice versa with regards to the other fraction. And so sometimes in a textbook, your answer you may write your answer like this. The textbook may write it, and more likely to write it, or mark schemes, if you're looking at exam papers, may write in the other, but they're both the same thing. So as long as you're able to understand that, then you're going to be absolutely fine. But again, the reason why people flip it, so write b first rather than a, is in case it starts with a negative. So let's have a look at our last example in this. Now here you can see that we haven't got two brackets, but one thing you should be able to spot is that this is dots. It's a difference of two squares. So in this particular question, we need to first establish that this is 12x plus 8 over, it's going to be 2x minus 1, 2x plus 1. Now, another thing that a lot of students may be tempted to do is they may notice that this can also be factorised. So you can take out a common factor of 4 and go from there. Now, you don't really need to do it because you don't want fractions cancelling out with others if that's what you're thinking, but in most cases that won't be the case. So from this, what I can then do is start by writing and breaking this up as my partial fraction. So I've got a over 2x minus 1 plus b 2x plus 1. And again, so it's just one of these things that you just have to spot that is a dot. So from this, what we get is 12x plus 8 equals a, and that's going to be times the other denominator, which is 2x plus 1, plus b times the other denominator, like so. So from this, to make that bracket equal to 0, x needs to be equal to minus a half, and to make this bracket equal to 0, x needs to equal a half. So it can be fractions, so that's something just to bear in mind. So when x equals minus a half, we get 12 times a half plus 8 equals, now if it's minus half, that's the a is going to cancel out, so I'm going to be left with is b, and it's 2 lots of minus a half, take away 1. And if you're not confident with multiplying fractions, but that's going to be minus 6 plus 8, which is 2, equals 2 times minus a half is minus 1, and minus 1 times minus 1, take away 1 is minus 2, so it's minus 2b. So b equals minus 1. There's my first value. And now another thing is setting workout. Now I personally would set your workout and your solutions exactly what I've done. Some cases you may want to skip steps, but do not skip everything. Okay, you're not going to get any extra marks by doing everything in your head, so make sure you are writing it down. And it's also, even me as a teacher, for all the experience I've got, I still make silly mistakes. And the reason why I make silly mistakes is I'm trying to do too much in my head, to try and think, oh, let's just get the answer done as quickly as possible. But when you have that mentality, that's where silly mistakes always creep in. So make sure you take your time, and so that you don't have to then spend extra time checking your answer, and with about 3 minutes left in your exam realise, oh, I've made a stupid mistake, and you're going from there. To continue with the question, I then need to make x equals positive a half. So what I've got is I've got 12 times a half plus 8. So that's going to be 6 plus 8, which is 14. And that's going to be equal to, now when it's positive half, that bracket, the first bracket is going to equal 0. So I've got a lots of 2 times a half plus 1. So that then equals 1 plus 1, which is 2, so I get 2a, so a equals 7. So looking at this then, once I've got my two values, I can then write my answer in its whole totality. So I've got 12x plus 8 over 4x squared minus 1, and that's going to be equal to a over 2x minus 1 plus, oh, and that's a minus because b is negative, so let's get rid of that. And that's going to be minus 1 over 2x plus 1. Now, if you did write your answer as 7 over 2x minus 1 plus minus 1 over 2x plus 1, then you should still get the correct mark. But being A-level maths students, you should be able to spot that a plus and a minus equals a minus. But again, it'd be very harsh for them to lose a mark. But it's like writing a sentence without writing a full stop.